Welcome to another episode of Terry's Notes, and today we are going to be looking at January 2015 question 2. Okay, so different halogens combine to form compounds, and one such compound is ICl. Right, we know that iodine and chlorine they're both in group 7, right, meaning that they have 7 electrons in their outer shells. Now in the space below, draw a diagram to show the arrangement of the electrons in the chlorine atom. Now the atomic number for chlorine they gave us as 17, right, which means that the electronic configuration will be 2, 8, 7, right? If we add up these numbers here, we should get 17. We know that in our first shell we will have 2 electrons, our second shell will have 8, and the remaining electrons will fill in the third shell, right? So 2 plus 8 will give me 10, and 10 plus 7 will give me 17. So we want to show the arrangement of the electrons in the chlorine atom. So what we do, we draw the nucleus, and all we're concerned about is the electrons. So in the first shell we have 2 electrons, so we could write this as 1 electron, and we have 2 electrons. And then we draw the next shell, which we know it should contain 8. So we have 1 electron, 2, 3, 4, 5, 6, 7, 8 electrons. And we have to draw the last shell, which will have 7 electrons. So we go 1, 2, 3, 4, 5, 6, and one more, which will give us 7. Right? So this is what this shows the arrangement of the electrons in the chlorine atom. Right? So in the outer shell we can see we have 7 electrons. You do not need to draw your electrons like how I did. You could have just shade it and just label it as, give a key and just call it electron. Alright, whichever one you are comfortable with and which is easier to draw for you. Now this second part here is that using valence shells only. When they say valence shells, they mean outer shell electrons. So this is outer shell electrons, right? And we are looking at the compound ICl. Now both of them are in group 7, so we know that the type of bonding will be covalent, and we know that they are going to share electrons. So we're only concerned with the outer shell electrons, right? So in a covalent bond we have electrons being shared. So I will draw, let me call this iodine, an iodine atom, and we have a chlorine atom. So in the iodine we know that we're going to have 1, 2, 3, 4, 5, 6, 7 electrons, right? Now for the chlorine atom I'm going to draw the electrons slightly different so you can see the difference. 1, 2, 3, 4, 5, 6. I'm going to put the 7th one here. So therefore we have 2 electrons sharing the 2 electrons being shared in a covalent bond, right? So this is how you would draw your diagram for ICl. We are only concerned with the valence shell electrons or the outer shell electrons, right? Each of them have 7 electrons in the outer shell, Therefore, each of them will provide one electron towards the covalent bond. Let's move on to the next one. They said state 2 reasons why ICl is expected to have a low melting point. Now, even if you are unfamiliar with the compound ICl, right, just know that within group 7, remember we have fluorine, chlorine, bromine, and iodine, right? And they exist as diatomic molecules. So they exist as F2, Cl2, Br2, and I2, right? And they exist as simple covalent molecules, and they have weak forces of attraction between the molecules. So state 2 reasons why ICl is expected to have a low melting point. Well, the first thing we can say is that it exists as a simple covalent molecule. So everybody handwriting, right? With weak intermolecular forces, intermolecular forces between them, right? And the weak intermolecular forces are what we call van der Waals forces, right? So basically ICl will probably exist something like this. So you have the ICl molecule will look like this, and if we have our next ICl molecule and another one somewhere here, right, we're gonna have forces existing between the molecules, and this force is weak, right? So this here would represent a simple molecular, right? It's a simple covalent molecule, so it's simple molecular, and there are weak forces between them. So therefore, it is expected that ICl will have a low melting point, right? Now, I think in one of the videos I mentioned that even though something has covalent bonding in it, it doesn't mean that it is expected to have a low melting point all the time. Because think of something like diamond. Diamond is a giant covalent structure, but even though it's covalent, the covalent bonds are very strong, and diamond has a high melting point. Now, part C is an analysis of a sample of ICl shows that it consists of molecules of the same molecular formula, but with different molar masses, right? So when they say same molecular formula, they mean this is the molecular formula, ICl, right? So they're analyzing a sample of ICl, and they notice that they have molecules inside it, and each of them has a formula, a molecular formula of ICl, but the molar masses are different, right? So when they say molar masses, they mean 1 mole of ICl, right? For some of the molecules seem to be different. Now, why is that? Now, let me show you something. Remember, chlorine has 2 isotopes, chlorine 35 and chlorine 37, right? And we know that based on the isotopes, the relative atomic mass of chlorine is 35.5, right? So this is what you need to say. You have to say that the sample contains isotopes, right? And when we say isotopes, it could be for the iodine or the chlorine. And in case of chlorine, we know what the isotopes are. The isotopes are chlorine 35 and chlorine 37, right? and the different isotopes could add together to give us different molar masses. So you could have something like ICl, but instead of, you can have ICl ICl with 35, or you could have ICl 37, right? And then whatever other isotopes you could get with iodine, right? The thing is that when you add up the masses, you're going to get a different molar mass, right? So this one will give you one molar mass, and this one will give you a different molar mass, because even though it's chlorine, you could have chlorine 35 or chlorine 37, right? Now look at the amount of marks. It's 3 marks, so chances are they want us to say that there are isotopes present, and the isotopes could either be for the iodine or the chlorine. And then we need to say that when the different isotopes are added together, different molecular masses can be obtained. Okay. The next one is to write a balance equation for the reaction that occurs between chlorine and aqueous potassium iodide. So we're going to take chlorine, which is Cl2 gas, and we're going to add it to Ki aqueous, and we're going to get 2 KCl aqueous plus I2 solid, right? It should be 2 Ki here, right? This is simply a displacement reaction. Now this would have been on the one of the other videos with group 7. So we have fluorine, chlorine, bromine, and iodine. And if we take one of the elements that are higher up in the group and react it with one that is lower down in the group, which is an aqueous solution, a displacement reaction will take place. So we'll look at where chlorine is and look at where iodine is. Chlorine, when bubbled through an aqueous solution of Ki, is going to displace iodine solid, right? So the chlorine gas goes into solution as Cl minus, and the iodine, the Ki, aqueous Ki, iodine comes out as iodine solid, right? So this is something pretty straightforward. You just need to remember this. And it said based on the balance equation you have written, determine the change in oxidation number of the iodide ions. Okay, so if you go back to our equation, we initially started off with Ki. So let's do the oxidation numbers here one time. So if we're looking at the iodine here, the iodide ion, the oxidation number will be initially -1, and then we end up with iodine, which is I2 in its solid state. Therefore the oxidation number is 0. So we're moving from -1 to 0. Okay, so they said based on the equation written, determine the change in oxidation number. So the iodine is going from -1 to 0, right? And you have now to determine whether chlorine is acting as an oxidizing agent or reducing agent. Now what happens to the iodine? Remember, chlorine is being bubbled through a solution containing iodide ions, right? In the case of the iodine, well, the iodide ions, we go from -1 to 0. So therefore we have an increase in oxidation state or number, right? So you're going from -1 to 0. So therefore we know that this is oxidation, right? Therefore chlorine is acting as an oxidizing agent, right? So this is the solution for the last part. All right. Like I said, with chemistry, you cannot cram chemistry. You need to continuously revise your notes. Okay.